This video is on the objective graph a lemniscate from a polar equation. And this is the second video on this objective. I'm hoping you've seen the first one. Remember, this lemniscate is a special kind of curve. It looks like a figure eight or a infinity symbol. And it involves, r squared equals some number times the sine or cosine of 2 theta. So let's take a look. So here we have, again, if you want to see more on the topic, click on More Instruction at the bottom of the problem. Look at their notes, their videos, their examples, and hopefully those help you. So we're seeing r squared equals some number, times the sine or cosine of 2 theta. Any equation of this form is going to take on the shape of the lemniscate, or this figure eight or infinity symbol when we graph it on the polar grid. Alright, so let me draw this up. I'll show you how I would go about doing this by hand, and then I'll just show you the picture on Desmos, desmos.com, free online graphing calculator. So I have r squared equals negative 25 times the sine of 2 theta. Alright, so now remember r, right, the value of r is a real number. Right, r is coming from the polar axis on the graph, and the polar axis is just a real number line. Whenever you square a real number, it's got to be non-negative. So what I'm going to do here is I'm going to find the values of theta for which this expression here on this side is non-negative, for which negative 25 times the sine of 2 theta is greater than or equal to 0, right? Because if this ended up being less than 0, if this ended up being negative, this would have no meaning, right? Having r squared be negative. We're talking real numbers here, not imaginaries, not beyond the reals. All right, so what I'm going to do is I'm going to look at the graph of this equation. Y equals this expression, negative 25 times the sine of 2 theta. So here y is representing values of r squared, and I meant to replace theta with x, sorry. And x represents values of theta. Right, so I'll label that on my axes. X represents values of theta. Y represents values of r squared. Okay. Now the period of this sine of 2 theta would be pi. The sine of 2x. Well, let me rewrite this. Negative 25 times the sine of 2x. This has no phase shift. The period would be pi. And so if I went to 2 pi, I'll be drawing the same graph twice. And the period's pi, I'll cut this into quarters. So we're going to go every pi over 4 here. And then same thing over here for this, cut it into quarters. This would be 5 pi over 4. Okay. And I'll be seeing the same picture twice. The amplitude is going to be 25, right? 25 up here, negative 25 down here. And the sine of 0 is 0, starting here. And when I plug in pi over 4, I'll get, negative 25, and then plug in pi over 2, I'm back to 0, then positive 25, back to 0. And then this picture, this wave will repeat over here. So there's a picture of this graph from 0 to 2 pi that'll take me once around the polar grid when I draw up a polar grid. Now the only values that actually mean anything to us are these here, where the outputs are positive. Right? all these down here are pointless. Right? This parts of the graph, these mean nothing because I have negative outputs, and you can't have r squared be a negative number. Right? So the only values of theta that are allowed in this equation, the only values of theta are between pi over 2 and pi, because I'll get positive values here, and between 3 pi over 2 and 2 pi. All right, so now I'm going to do the square root, right? This is where y is r squared. Now we'll look at the square root, right? Let's take a look at r equals, now you could say plus or minus the square root, but I'm just going to look at the positive one. You may have seen in the first video that there's symmetry with these lemniscates. You don't need to look at both the positive and negative square root. So I'm just going to look at the positive square root of negative 25 times the sine of 2 theta. All right, and this will give us the graph of our lemniscate. So looking at y equals, the square root of negative 25 times the sine of 2x. That's just going to be taking this graph here, and now, again, the x-axis represents values of theta, and now the y-axis represents values of r. And it'll really just be these humps, but shortened. Right? You got from pi over 2, and then you got pi over 2, 3 pi over 4, pi, right, where their values are positive. I'm just taking the square root of this. So instead of going up to 25, take the square root, it's going to go up to 5, right? So it's going to be kind of like a condensed hump there. And then there's no graph between 0 and pi over 2, no graph between pi and 3 pi over 2 because the values were negative, and then from 3 pi over 2 to 2 pi, I'm getting a condensed hump here, right? The highest point will be at 5 at 7 pi over 4, and then, yeah. All right, and this is the graph I want to look at. I'm going to look at this graph when I go to make my graph of the polar equation on the polar grid. All right, so let me make a polar grid. So you got your vertical axis, right, which really means nothing. The horizontal axis, which is the polar axis, and again the largest value r, this is r now, not r squared, the largest value r is getting is 5. All right, so 1, 2, 3, 4, 5 on the polar axis, and I'll draw this circle with a radius of 5 around the polar axis, around the pole, right? Remember, you're traveling on circles when you're graphing in polar. All right, so there's a circle radius of 5. All right, and then another thing I'm going to put up is all these special angles that came up on my original graph. I'm going to cut the quadrants to every pi over 4, right? Because all these notches here are every pi over 4 apart. So I'm going to draw some lines to represent the angles every pi over 4, right? There's theta equals pi over 4, here's theta equals 0, right? Pi over 2 for the positive vertical axis. Then there's 3 pi over 4, pi, 5 pi over 4, then 3 pi over 2, 7 pi over 4, and there's every pi over 4, okay, and then back to 2 pi, right? All right, so looking at this graph up here, all right, with the values of r and not r squared, with just the two little humps, between 0 and pi over 2, no graph. All right, between 0 and pi over 2, absolutely no graph. Between pi over 2 and 3 pi over 4, so between here and here, looking at this piece of the graph, I'm going from r equals 0, right? Y represents r here. R equals 0 at pi over 2 to r equals 5 at 3 pi over 4. So this point here. All right. So and then it's going to be, the value of r is going to increase and then come back, increase and get out to an r of 5 at 3 pi over 4. So maybe something like this, and curve. Don't draw a straight line. It curves out there. All right. And this is kind of like half a petal in your rose curves when you talk about rose curves. All right, then from 3 pi over 4 to pi, that's between here and here, we're going back down to 0, right? R equals 5 back down to r equals 0, so that's like the other side of this, right? Something like that. All right, then between pi and 3 pi over 2, no graph. no graph. Those values of theta were bad. Then between 3 pi over 2 and 7 pi over 4, so between here and here, 3 pi over 2 and 7 pi over 4, this part of the curve, I'm going from r equals 0 to r equals 5 again. So 0 to 5. So basically it's like this down here, right? And then from 7 pi over 4 to 2 pi, between here and here, I'm going back down to 0. And there's your figure 8. There's your lemniscate, right? This infinity symbol, right? Let's take a look at a better picture of this. All right, so that's all well and good by hand. But let me go to that Desmos website, right? Desmos.com. And I'm going to put in, now you can't put in r squared equals, you have to solve for r, get r to the first power. So I'm going to put in that square root, right? R equals the square root. Just type in SQRT of negative 25 times the sine of 2 theta. And you just type in theta. And there's the lemniscate I just drew. Right? Figure 8. And as we said on my picture, my drawing, my hand drawing, right? Those points at the ends of the lemniscate, the far ends, are 5 units away, right? They should be on a circle with a radius of 5 if I put r equals 5, right? You see those points at the end of the lemniscate are 5 units away from the origin. All right, so when I'm going to make my choices here, that's not good, that's not good, that's not good. This one, that's the only one that's actually oriented the right way. So this is the lemniscate, which again you could have just done by plugging this, taking the square root, solving for r, and putting it into Desmos, and then comparing which of these options look like the Desmos picture. I know you could do that. I just wanted to show you again how to work these by hand as well if you absolutely needed to. All right, and then let's submit and see that I'm correct, of course. Blah blah blah, and then great. All right, so hopefully watching me do this, playing around on Desmos or whatever graphing calculator you have, if you know how to graph in Polar. Looking at the more instruction when you need to, reading the answer explanations when they come up. Hoping all this stuff helps you, when you work on this material on your own. Okay, and thank you very much for watching.